All right, good morning, good afternoon, whenever it might be that you're watching this video. We're going to continue our lesson from Friday on simplifying square roots and talking about an expression that you're going to see that commonly results from solving quadratics using the quadratic formula, which is tomorrow's lesson. So today we're going to work on simplifying those expressions, and we have to talk about first something new that you probably haven't seen just yet in math, and that's the imaginary unit I. All right, so I know that it's a variable, but in math, that variable I stands for the imaginary unit. Okay, so what is the imaginary unit I? Well, if we consider the square root of -1, if you plug that into a calculator, your calculator is going to say error, non-real number. Okay, so we have our real numbers, which we've talked about this year. We've talked about domains being all real numbers. Those are all the numbers that you can put on a number line from -infinity to infinity. The imaginary unit I, or imaginary numbers, are a different set of numbers. You can't find those on the XY axis. Okay, so where do they come from? Well, if we consider the square root of -1, we let that be I. That's how we define the imaginary unit I. It's the square root of -1. All right, so we can do some things with that. We can say, well, what then is I squared? Well, I squared would just be the square root of -1 squared, which the square root and the square cancel each other out, leaving -1. So I squared is -1. Which is interesting because you square an imaginary number, you get a real number. All right? So then I cubed would be the square root of -1 cubed, and if we group this in a special way, we can say that's the square root of -1 squared times the square root of -1 to the first power, but I don't need to put that first power, right? So this is -1 times the square root of -1, or we could simply write negative square root of -1. And finally, we could go I to the fourth, which is equivalent to saying the square root of -1 to the fourth. And again, grouping these in this way, we'd have the square root of -1 squared times the square root of -1 squared, which is -1 times -1, which is 1. And this cycle repeats. If we go to I to the fifth, you'll see that it comes back to just I. I to the sixth is the same thing as I squared, and this cycle repeats for any exponents greater than or equal to 5. So I'm going to write that down. This pattern cycles for any exponent greater than or equal to 5. All right, so this isn't real important, just some kind of interesting things that happen when you deal with the imaginary unit I. The main thing that you need to know for today's lesson is this fact right here, because we're going to use it to simplify the expressions you'll see here in a second. Okay, so this is also a note. Okay, any number that can be written in the form a plus bi or a minus bi. So when you have these two expressions, in math a lot of times we write it like this, a plus or minus bi. We call this type of number a complex number. Okay, so a complex numbers are a different set of numbers than the real numbers. All right, and we're going to start talking about complex solutions when we get to the quadratic formula and what that means, but I'm just introducing you to the term in this video. So, is a complex number. So anything in the form a plus bi or a minus bi is called a complex number. All right, so now this is coming from your notes page. The directions should say to simplify. That's not on there, so please add that. I'm going to simplify some of these expressions, and these are the expressions you're going to get when you use the quadratic formula. So today's lesson is just how do we simplify these expressions. All right, so starting with number one, we have -4 plus or minus the square root of 4 over 2. So with these with these expressions, to simplify them, always start with the square root. All right, so the square root of 4 is 2, so I can rewrite this expression as -4 plus or minus the square root of 2 all over 2. Okay, now you always try and simplify further. So these are all whole numbers. I can combine them and then divide by 2. So I'm going to make this into two different expressions. One is going to be -4 plus 2 divided by 2, and the other is going to be -4 minus 2 over 2. All right, now just do the arithmetic there. We have -2 over 2, which is -1. -4 minus 2 is -6 over 2, which is -3. So that is the simplified version of this expression. All right? So let's go on to number 2. We have 4 plus or minus the square root of 176 over -16. So in this problem, I have to start with the square root. 176 is not a perfect square. Now, it's a little bit hard to think of what perfect square is a factor of 176. So here's where I like to use the prime factorization method. So I'm going to do that just right here. Okay, so I start with 2. 2 times what gives us 176? And it's 2 times 88. 88 is 2 times 44. 44 is 2 times 22. 22 is 2 times 11. So then I like to circle my pairs because those are my squares. All right, and also 11's a prime, but it's a singleton. So I'll show you what we're going to do with that in a second. So this expression can be written as 4 plus or minus the square root of 2 squared, that's this pair here, times the square root of 2 squared, I'm using the product rule for square roots, times square root of 11. And that is all over -16. So now I'm just simplifying that square root. So you have 4 plus or minus 2 times the square root of 11 over -16. Okay, further simplifying, I have 4 plus or minus 4 square root 11 over -16. And I'm going to pause here because this is where the common mistakes are made. A lot of students want to combine 4 plus 4 and 4 minus 4. But if you do that, you're putting addition and subtraction before multiplication. This 4 is multiplying the square root of 11. So what can we do? Well, we have to see if this term are divisible by anything that in this term on the bottom. All right, so I notice that all of these numbers have a factor of 4 in them. So I'm going to factor out a 4 from the top and the bottom. So I have, when I factor out a 4, from this I just have 1 plus or minus. I factored out this 4, so it's going to be 1 times the square root of 11 over, I'm going to factor out a 4 from -16, so I have 4 times -4. Now why would I want to do that? Well, now this 4 and this 4 cancel out, leaving us with 1 plus or minus the square root of 11 over negative 4. And that is fully simplified. Okay, so there are quite a few steps here just in simplifying this. It really helps if you get good at simplifying square roots so that it doesn't take a whole lot of time to get from here to here. All right, and once you do enough of these, it does become easier and you do start to see some patterns, and you will speed up as you practice this. All right, so let's go with another one. Oop, I repeated that one. Oops, I goofed. So this is number 2 on your paper. But I'll do it as number 3. All right, so this is number 2 again on your paper. All right, the problem I just did was number 3. Sorry for the mix up there. All right, so we start with the square root. Notice the negative underneath the square root. So when there's a negative under the square root, that's where I is going to come into play. So I can change this to be the square root of negative 1 times the square root of 4 all over 2. So that's using that product property again. All right, so the square root of negative 1, like we just went over, is I times square root of 4 is 2 all over 2. So then we have negative 4 plus or minus 2i. We normally write the real number in front of the I. That's just a stylistic thing. Okay, we still have divided by 2. Now we look to see if there's a common factor in negative 4, 2i, and 2. Well, we see that, yes, there's a common factor of 2 on the top, and we have 2 on the bottom, so this is going to become 2 times negative 1 plus or minus I divided by 2. So the 2's cancel out, and we're left with negative 1 plus or minus I. And we've just simplified that expression. Okay, number 4. Number 4, let's get this over. All right, number 4, we need to start with the square root of 72. So 72, if I start breaking that down into its prime factors, is 2 and 36. So 72 is 2 times 36, and I notice right there, there's a perfect square. Okay? So 8, we have 8, so this is a new problem. We're going to have 8 plus or minus the square root of 36 times the square root of 2 over negative 2. All right, so then we have that's equal to 8 plus or minus 6 square roots of 2 over negative 2. So there's a common factor of 2. So the top becomes 2 times 4 plus or minus 3 square roots of 2 over negative 2. The 2's will cancel, but in the bottom, we're still going to have a negative 1. Okay, so the top will become 4 plus or minus 3 square root 2. And now we don't want to put divided by negative 1. Okay, we can divide each of these by negative 1. Well, 4 divided by negative 1 is just negative 4. If you have positive 3 square roots of 2 divided by negative 1, you're going to end up with negative, and if you have negative square root 3, or 3 times square root 2, you end up with positive, so that plus or minus still says plus or minus. So this is simplified. We're simplifying some more of these expressions that would result from using the quadratic formula. You're going to see this again tomorrow. So looking at number 5 from the notes page, we have negative 2 plus or minus the square root of negative 36 over 4. So I first noticed that 36 is a perfect square and it's negative, so that's going to result in an I. So this reduces to negative 2 plus or minus 6I all over 4. Okay, and just like the previous problems, I'm now going to check and see if there's a common factor between negative 2, 6I, and 4, which there is. There's a factor of 2, so I'm going to factor out a 2 from the top. And I'm left with 1 plus or minus 3I all over. 4 has a factor of 2 in it. It can be written as 2 times 2. The 2's cancel out, so I'm left with negative 1 plus or minus 3I all over 2. And that's fully simplified. Okay, moving on to the next example. We have 3 plus or minus square root of negative 31 over 2. So first thing I notice is 31 is prime, but I can still simplify the negative there and bring out an I. So I'm going to have 3 plus or minus I square root 31 over 2. Now 3, I, and 2 don't share any common factors, so that is simplified. All right, next one. I have negative 3 plus or minus the square root of negative 162 over 6. So I'm going to start with the square root. So I need to simplify 162, which I think I've done. Maybe not, can't remember. I have 2 times 81. Now, when you're doing the factor tree, if you see a perfect square, I'm going to rewrite that as negative 3 plus or minus. Well, first off, I'm going to take that negative 1, put it underneath the square root, times the square root of 81 times the square root of 2. Okay, I'm not going to break this down because I know that 81 is a perfect square. So this is all over 6. Okay, so now I have negative 3 plus or minus the square root of negative 1 is I, the square root of 81 is 9. So I have plus or minus 9I times the square root of 2 all over 6. All right, so the top, negative 3, 9, and 6 all share a common factor of 3. So I'm going to factor out a 3 from the top. I'm left with negative 1 plus or minus 3I times square root of 2 all over 3 times 2. So then the 3's cancel out, and I'm left with negative 1 plus or minus 3I times the square root of 2 all over 2. Okay, last one, I have 8 plus or minus square root of negative 72 over 6. So again, start with the square root. 72 is 2 times 36. I'm going to stop there because there's my perfect square. So I have 8 plus or minus the square root of negative 1, factoring out that negative 1, times the square root of 36, times the square root of 2, all over 6. Okay, so that is 8 plus or minus 6I square root of 2 all over 6. Now 8, 6, and 6 all share a common factor of 2, so I'm going to factor out a 2 from the top and bottom. So the top's going to be 2 times 4 plus or minus 3I square root of 2 all over 2 times 3. 2's will cancel out, and we're left with 4 plus or minus 3I square root of 2 all over 3. And that's our final answer. So, practice this. You can go through this video and pause it at different points and then try and get the answers that I did. That's a good practice. Tomorrow we'll start the quadratic formula and how to solve quadratic equations using the quadratic formula. So be looking for that. Good luck, and let me know if you have any questions.